Myself RAM SINGH. So today we will discuss about the very important chapter in the algebra is known as function. Okay. So before starting function, we can retake about the relation. After that we can start function. Okay. So as you know what is relation. Okay. So we can simply define the relation as relation is a relation is a subset of cross product of two non-empty set. Okay, sets A and B. So you all know how we can represent a relation. If a relation is defined from a function A to B, then we can write relation which is defined from A to B. Okay. So if you want to represent a relation in the set builder form, then you can simply write relation the ordered pair AB, where in the relation R there exists ordered pair A and B such that A belongs to first set A and B belongs to second set B. Okay, there is a unique definition of relation. Okay, so with the help of this definition we can derive the definition of function. Okay, so let write here what is the definition of function. Okay, so function. Okay, so we can say that function is a rule which is defined from function is a rule which is defined from a non-empty set A to a non-empty set B, in which we can find a unique element in set B for each element in set A. Okay, so this is the definition. So we can discuss what is the meaning of this definition with the help of another example. First let me elaborate what is the meaning of this. So if such type of two functions is exist, then we can symbolically represent it as function from A to B. Okay, so as you see here is written, in which we can find a unique element in set B for each element in set A. Okay, if there is this rule is violated, if we find two elements in set B for any element in set A, then we can say this is not a function. So let me explain some more these things with the help of arrow diagram. So let's suppose there is a function defined from set A to set B. Okay. So let's suppose in the set A there is element A, B, C. Okay, and here 1, 2, 3, and 4. Okay. So we can, if we define this relation, that is, let's suppose this A is related to B, B is related to 2, and C is related to 1. Okay. So in this we can find a unique element in set B, for each element in set A. There is A is related to only 3, B is related to only 2, C is related to only 1. Then we can say that here this is a f is a function. Okay. But let me take another example. If we define a relation in set A to set B. Okay. So let's suppose here A, B, C, and D, and here 1, 2, 3, 4, and 5. Okay. So if you define this rule with the help of these things, A related to 1 and A related to 5, B related to 1, C related to 2, and D related to 4. Okay. Then in this example we can see that here A is related to 2 elements, 3 and 5. Then this is a violation of the definition. That is, here is a pair in which we can find a unique element in set B for each element in set A. But here we can see that A is related to 2 elements in set B. Then we can say that this is not a function. Okay. So there is the 2 examples with the help of which we can simply find definition of the function. Okay. And if we write in the relation term, so then we can say that a relation is called a function if each element in set A related to a unique element in set B. Okay. So the definition which we discuss here and written here, both are same. We can say a relation also be a function. A relation also be a function if each element in A is related to the unique element in set B. Okay. But if we write one, let me take one more example with the help of which we can simply elaborate the one condition also. So let me erase this. So if we write one more example here. Okay, 1, 2, 3, 4, and here A, B, C, D, E. Okay. So in this case, if we define, let A related to B, 2 related to D, 3 related to B, and this type of function. Okay. So A and B, let us say this is a function. So each this is a function. Then in this case we can see here 1 is related to unique element B, 2 is related to unique element C, 3 is related to unique element B. But here we can see that 4 is not related to any element. But in the definition you can see that find a unique element in set B for each element in set A. But in this example we will see here, we can see here that 4 is not related to any element. Then in this case we can write, since 4 is not related to any element, that's why we can say that f is not a function. Okay. So with the help of these three examples, we can simply find the clear meaning, clear definition of the function. That is, if all the element in set A is related to one and unique element in set B, then we can say that this is a function. There is no matter if there is one any element is remaining in set B, but in set A all the elements must related to only one element, that is single element in set B. So this is a function. But in the second diagram, here we can say that all the elements here are related. All the elements in set A are related. First thing is completed, that is all the elements is related. But there is a second thing. A has two images in set B, that is 3 and 5. That's why we can say that this is not a function. In the example 3, we will see here 1, 2, 3 are related. One or only one single element. One is related to B, 2 is related to D, and 3 is related to B. So there is no matter if two elements in the A set are related to single element. There is no problem. But here is 4 is left out, which is not related to any element. That's why this is not a function. Okay. So in this case, we can simply see that if each and every element of set A is related to unique element in set B, then this will be a function. Otherwise, not. Okay. So I hope the definition of the function will be clear. Okay. Now we can discuss second thing is domain and codomain of the function. After that, we can discuss types of function. Okay. So let me read this here. So for domain and codomain, we can write domain and codomain. Okay. So for this, let a function f defined from a non-empty set A to another non-empty set B. Okay. Let's suppose this is defined as f defined from A to B. Okay. Then we can say that domain. We can look at them. And B belongs to B. So this is the set builder form representation of a set. Okay. So either we can say that this is f function defined from A to B, or we can say here function f is defined as you can write like this: A, B, where A belongs to A and B belongs to B. Okay. So we can say that for domain of function f. So लिखेंगे set all set A, all, or we can write simply whole set A will be the domain of function f. Okay. So if you remember, I told you in the definition all the element of set A is related to only one unique element in set B, then we can simply say that if a function f defined from A to B, then we can say that first set A, here first set from where the we defined a function, we can simply say that this is the domain set of the function. Okay, and second thing, if we want to know about the codomain, then we can simply write here codomain. Okay, so codomain. Okay, so whole set B is known as codomain set of F. Okay, so set A is known as, here we can write set A is known as domain, and set B is known as codomain. Okay, there is two things, and a third thing which is very most important in the function, that is range. Okay, so what is the range we can discuss here. So definition of range we can write set of all elements from set B which is related to any element in set A is known as range. Okay, so we can simply write. Okay, this is the definition. So I know there is no meaning of the definition if we not explain with the help of example. Okay, so with the help of one example we can simply write what is the definition of this, what is the meaning of this definition. Okay, so if we write, there is a function f. Okay, so here is A, B, C and D. 5, 6, 7, 8, 9. Okay, so let's suppose this A is related to 6, this B is related to 5, this D is related to, C is related to 9 and D is related to 7. Okay, so let's suppose this is set A and this is set B. So here is a function, then we can see all the things, the range, domain and codomain of the function. So if we want to know that the range and domain and codomain of the function, so first of all if we write domain of functions, as I told you, we can write all the set A, that is A, B, C and D. Okay, this is the definition. And codomain, as I told you, codomain of F. So here if we see definition, the codomain of the function, then we can write all the set B, that is, if we write all the set B, so simply write set B. Okay, so set B, in the set B there is element 5, 6, 7, 8 and 9. Okay, but if you want to write range, so we can write a range here, simply range of function f. So as you see here definition, set of all elements from set B which is related to any element in set A is known as range. Okay, so we can take only those elements which is related to any element in set A. Okay, so here we can see simply 5 is related to any element. We can see 5 is related to B, so we can write 5. 6 is related to any element, so here we can see that 6 is related to A, so we can write here 6. So and 7 is related to D, so we can write 7 also. And D, 9 is related to C, so we can write 9 also. Okay, so there is a range of the function. We can simply see here 5, 6, 7 and 9. Okay, so we can left 8 because 8 is not related to any element in set A. Okay, so I hope all the things will be clear about function, range, domain and codomain. Okay, so see once and note this. After we will see the types of function. Okay, so let me erase this.
इरेज कर दीजिए, अब वीडियो को पॉज कर सकते हैं, कोई दिक्कत नहीं है।